Perfect. Good afternoon. Thank you for inviting me here today to talk about a subject that I care deeply about. And thank you for spending the next 15 minutes with me. When you think about 3D microelectronics and research and 3D packaging, you can think about all the things we talked about in the last day and a half, right? Advanced processing technology, integration technology, new processes, a new way of doing integration, new way of thinking about tackling the problem, the supplemental technology that goes with it. Well, I'll tell you today that I'm not here to talk to you about that. I wanted to offer a different conversation. And the conversation goes something like this. From the technology integrator perspective, or the consumer perspective, or from the technology ingestion perspective. Because when you think about 3D microelectronics, 3D packaging, you think about all the things that it can enable. I am going to categorize your customer into two different categories. The first set of category is you think about enhancing existing capabilities. Think about the things that you might want to replace, things you want to do better or differently, but it's an existing capability that we currently have, and perhaps it's not quite adequate to do what we want to do today in a changing environment. I would say the second set of customer is the new capability customer, the customer that desires certain capability, and yet there's no way to get there, or there's no good solution that exists today. So if you're a researcher and you are a technologist, and then you are a DARPA performer, you kind of step back and think a little bit about the DARPA's mission. DARPA's mission is to make pivotal investment for national security. Well, that's certainly true that DARPA makes investment, a lot of investment. Certainly they're pivotal. But in order for something to happen and make impact to national security, it has to go through means of either platform, capability, infrastructure, or a new way of doing business, right? In terms of understanding what's out there, what things we can do. So this perspective, what I want to talk about today is the infamous valley of death, the view from the other side of the valley. And here's really the goal. The goal is to hopefully shine some light into some of the thinking behind the people that may want to take your technology, but some of the consideration why they would not. And with the purpose of accelerating that understanding across the gap so that when you are developing the technology, when you're thinking about the next new thing, you have some consideration of how the information is going to be ingested, how the technology is going to be used, and therefore accelerate the field use of your technology. Because ultimately, that's what will make the difference on the field. But if you are kind of doing your technology development, which I was, of course, one of those, I think about some of the great things we offer, the typical stuff, right? Hey, I can offer you this performance. What about the size? Think about the weight, think about the power, think about the cost. Think about perhaps because of the packaging, I have a more reliable environment, and therefore I can offer some stability to the system. And best of all, I offer you new functionality. Why don't you like it? Well, there is an interesting mindset when you are trying to talk to the customer this way, because they don't see the technology in that view. They could, some ways, careless about how much improvement you make as long as you close the mission gap. In some ways, they kind of don't care about how much size advantage you have until they consider how they're going to use it. And let me give you some examples. So let's see. OK, so some of the implementation consideration. If you are a customer that is trying to enhance existing capability, what would you be thinking about when you come to the office and show me this shiny thing? Hey, look, I can do X times better. I have much smaller size. I can do this, I can do that. In the back of my mind, I will be thinking the following. I am a program manager. I have things to run. Risk, risk, risk. What kind of risk would this new technology bring in? What kind of things would I have to think about? Do I replace just the drop-in replacement for that little thing that you're offering me? Or do I have to change the connectivity and the infrastructure to ingest that advantage? Do I want to change the front end so I can better accommodate? Do I want to figure out how I will processing the information differently because of this new thing? And also, what are some of the system overhead I have to do? Do you require a new operating environment? How about a new voltage or new current that's going to introduce to my power systems? What about other things that I have to change in order for the other side, I say is a communication system, to receive, because I changed that piece? Because after all, the hardware or software or all the technology that goes into a thing is only 1/3 of the equation. The other third is the counterpart of receiving whatever information you got, and then the other third is how to process and utilize the information and get it to the user that you require. So I will be thinking about, in order to take this advantage of the offering you have, what are some of the unintended consequences that I have to bear? What are some of the unknowns do I have to go tackle? And then mostly, if I put this in field and it broke, what am I going to do with it? Do I take it back, replace it? Is there some other way that I can replace it? And then lots of questions then come up. How reliable is this thing? How fast can you get it to me? How much more money do you think you need to have? Right, the list just goes on. So this is, if you wanted to enhance the existing capability, we already know what the capability does. And then here comes the newcomer. So there is a little bit of come back when you're ready. But then you don't know how you're going to get ready, right? So let me pause here for a minute and talk about the other half of the customer, the enabling new capability customer. Now that's totally different, because my existing capability is not good enough. I don't have it. So I am thinking, instead of risk, I'm thinking about opportunity, opportunity, opportunity. Okay, what can this thing offer me? And they are perhaps going to be a little tiny bit intimidated about the 3D microelectronics or the 3D microsystem, because to them that's a chip. They don't know how to use it, the interface with it. So, but when you describe to them the benefit this thing can offer, they will start thinking about, hey, I can operate this thing completely differently. And because I don't have an existing infrastructure, it's not so bad. I can put some mobile infrastructure in place. I can do this, I can do that, I can do another way, or maybe I can tap into existing ways. So the CONUP change will be very beneficial. The equation of risk versus opportunity now is unbalanced. Now I am more excited about having new capabilities, right? And then if you think about the small electronics or the packaging that enables, you're kind of thinking about, okay, before I have limitations, perhaps it's a frequency consideration, perhaps it's weight consideration, whatever it is that we're trying to do from a size enabling perspective, what other things could I use for? And therefore I can maybe gather enough customer to be behind that. Similar argument for the performance and or any asymmetric advantage you can gain by offering the technology. But what is missing though is the link of this great technology with X amount of improvement to how it means to, what it means to me in operating and making a difference on the field. So I wanted to offer another perspective just for us to think about a little bit, and I'm gonna make some assumptions. So this is a typical life cycle consideration, very generic. You develop the product, you produce it, manufacture it, and then when it's sold and used, you support it. So you define what you want from a product perspective. You go design it, you make it, you qualify, certify, whatever environment that you want, reliability you want, and then you deliver, and by the time it's fielded, how do I maintain it? So the assumption I'm going to make is that any of the 3D electronics or packaging technology or all the new things that we're going to have to offer, we kind of know how to define it, design it, and how to build it. Decades of advancement in microelectronics technology, integration technology, additive manufacturing, wafer bonding technology, new processing technology, algorithm, the different way to do testing, methodology, all the things that you heard today, it's a pretty good set of, hey, once I know what I want to design, I know how to design it because tools are now becoming available, and more sophisticated, right? I kind of know how to make it because we have our infrastructure in place to make it. But from the mission utility and the end product user perspective, when you show up with the thing kind of half-made, I say we haven't really defined it that well. And defining what the good use of it will make a huge difference in accelerating that technology transition over across that valley of death. The mission requirement, a lot of times there's new mission. You don't even know what the requirement is. Maybe it's exploratory. So we do a lot of demonstration and certainly a lot of feasibility study and trying to get us there. But I wanted to spend 2 seconds about fielding speed. 10 out of 10 of your customer, my assumption, is going to say, if you have a 100% solution in 5 years and you have a 2-year solution to give me only 70, they will pick the latter because the technology and the capability is needed yesterday. So you have to think about the other half of the life cycle, and I challenge you to think about how much we actually think about it when we were designing those systems. Certification, qualification, testability. How do you interface with such small thing? Do we need to test every node like traditionally we do? Or we don't? Or we have a different test routine? Or we qualified it differently depending on the mission? How do we deliver? That is another thing that people don't really think about when you're doing the front-end design. Because you hadn't thought about where it's going to go, how it's going to integrate in a larger sense. What kind of interconnect does it take to go to the eventual level of fielding use? And also, when something goes wrong with it, am I going to take the whole thing and toss it out? And how do I replace it? Does it require solder? Or is it some sort of plug-in module that I replace, right? You kind of think about how the technology is going to be ingested. And then lastly, it's really interesting because every new capability has its value, but we value our men and women, right, on the field. Safety, user safety, absolutely critical, but we really didn't think about it a little bit. Is there a fail-safe when you're trying to change something using this new technology? What about the maintainability? Is it in the desert, that's dry heat? Is it out on the ocean, on a battleship? You have to think about all of that. And then maybe some stuff requires long shelf life before it's used, but it better work when I activate it. Right? So you kind of think about the field use, and then you think a whole circle and come back and say, okay, now I have all these considerations. Let me redesign or tweak the design that I have so I can come back and speak your language. Because those people that are making decisions today, that are fighting to maintain a capability, to deliver certain capability, are also the ones that know what's needed and what's most inadequate. But then they don't know how to articulate it because they're in that world, right? So let me leave you with a couple final thoughts. This is kind of just for you to consider as you design new technologies, 3D integration, and when you're trying to move the technology across the finish line. For 3D microelectronics and in connecting with the future system needs, please think about, try not to design everything till the nth degree. Try to think about maybe the 80% solution if it takes time off the fielding perspective. Think about the gap, the full life cycle gap, especially the latter half, which people don't tend to think about because the front end stuff is sexier, right? The back end stuff, it's kind of sweating out on the field and try to make it work. And the consideration of how your end user is actually going to use it. Is it transparent to the end users? It's really going to help in pushing the technology across the barrier. And then lastly, on the 3D packaging, usually the packaging aspect of it is really protect whatever it is that's in it, that it's being packaged, and offer an interconnection or some sort of connectivity between that system and the next system up or the next system next to it. But maybe think about packaging in an active sense rather than a passive sense. And there are a lot of possibilities. So with that, I'm going to leave you in your thoughts. Thank you again for inviting me here. Have a great day.